Okay, so in this problem here, what we're looking at is a car traveling 44 feet per second or 30 miles per hour. And a pedestrian or pedestrians walk out in front of this car. And we're looking for how long does it take to stop the car, this distance d. And we're given several things. So we have the normal reaction time of a regular person is 0.75 seconds. So by the time they see the person, it takes 0.75 seconds to actually hit the brakes. And then we have a person with blood alcohol content of around 0.1%, and their reaction time is much slower at 3 seconds. So we know that the car can decelerate at 2 feet per second squared, and we're looking at how long it takes the car to stop once you see pedestrians on the road. So this is kind of let's analyze the normal driver first, and this is a two-part question because we first need to figure out how far does the car travel before the person steps on the brakes. Okay, so that being, we'll call that d prime because it's not the total distance, it's just how far they travel before stepping on the brakes. And that distance is just going to be equal to the velocity times the time. So in this case, for the normal driver, we're traveling at 44 feet per second, and it takes 0.75 seconds before they start stepping on the brakes. And so that the person will travel 33 feet. But that's not the total distance. We need to take into account the car slowing down now. So taking into account the car slowing down, we can look at this equation. The velocity equals the original velocity squared plus 2ac if we have a constant acceleration, and then s minus s naught, okay, the distance given the original distance. All right, so in this case, we know our final velocity when they come to a final stop is going to be 0. The original velocity is 44 feet per second, and then we have 2, and the acceleration, the constant acceleration, the deceleration is 2 feet per second, so that's -2. And then we want kind of the final stopping distance, which is d minus the original, which we found out was 33 feet in this case. All right. So solving this equation, we get a total distance of 517 feet. So that's one of our answers. Now we can move on to looking at the person who's under the influence of alcohol. So just call this drunk. We have d prime. We're going to use the same equation, v times t. And we're still traveling at 44 feet per second initially. But the reaction time is much longer at 3.0 seconds. So multiplying these two together, we have 132 feet even before the person starts stepping on the brakes. Okay, so then we'll use the same equation up here above. The original velocity plus 2ac s minus s naught. We know the final velocity is 0 still, and original velocity, oh, I forgot my square up here. That should be squared. Squared plus 2 times -2 times d minus 132 feet. And solving this equation, we end up getting d is equal to 616 feet. So it takes the drunk driver almost 100 more feet to bring the car to a complete stop. So as the problem states, moral, if you must drink, please do not drive.